guys. So in this video we'll discuss about this problem 3 sum. So in this question we are given an array and we have to find all those unique triplets which sums to 0. So let us see one example first. So for this example we are given this array and the solution set consists of -1, 0, 1. So if you see, we have -1 over here, 0 over here and 1 over here, and if you sum all these three elements, this will sum to 0. The next is -1, -1, 2. So you have -1 over here, -1 over here and 2 over here. So if you sum all these elements, this will sum to 0. So now let us see how we can solve this problem. So in this problem we have to find all those I, j, k such that nums of I plus nums of j plus nums of k equals 0. So actually before solving this problem, let us try to solve a simpler problem, that is, let us try to find a pair I, j such that nums of I plus nums of j equals 0. So first we will solve this problem and then we will modify a solution to solve this problem. So over here we will find all those pairs such that nums of I plus nums of j equals 0. So what you can do is first you can sort this array. So let me just sort this array. So we will have -1, -1, 0, 1, 2 and 4. Let me just index this as well, and over here we will have 2 pointers, one at the left extreme, that is I, and one at the right extreme, that is j. So we are going to solve this problem using the 2-pointer theorem. So what you can do over here is you can simply check whether nums of I plus nums of j, in case this is positive. So in case this is positive or greater than 0, we want value equal to 0. So we actually have to decrement this nums of I plus nums of j. Now I can only move in the forward direction and j can only move in the backward direction. So what we have to do in this case is we actually have to decrement j. Why? Because the array is sorted. So array is sorted. So if you increment I, this value is going to increase, and if you decrement j, this value is going to decrease. And since the current value is greater than 0, we have to actually decrease it. So we will decrement j. Correct. And in case this nums of I plus nums of j is less than 0, you will simply increment I. Why increment I? Because actually we have to increment this value currently. And in case this is equal to 0, you have your I, j, so you can simply put them into some resulting list and you can increment I and you can decrement j. So let us apply this algorithm over this example given to us. So if you see, currently I is pointing to this 0th index and j is pointing to the 5th index. So nums of I plus nums of j is -1 plus 4, which is +3. So this is greater than 0. So you will decrement j. So j will come over here. Now over here -1 plus 2 is equals to +1. So again the value is greater than 0. So you will decrement j. So j will come over here, and over here you can see -1 plus 1 is 0. So actually you have found one pair. So you will add this pair 0, 3 to your resulting set. So this will solve the problem. So let me just show you the code for this thing and then things will be clear. So this is the code. So what we are going to do is we are going to maintain a resulting list. We will sort the array. Then we will have two values I, j, which are at the left and the right extreme, and you will simply loop this thing while I is less than j. So in case nums of I plus nums of j is greater than 0, you will decrement j. In case this is less than 0, you will increment I, and in case it is equal to 0, you will simply put I, j in the list and you will simply increment I and decrement j. So once this loop is done, you will simply return the resulting list, which will consist of all the pairs such that nums of I plus nums of j is equals to 0. Okay, so now let us move to the question that is given to us. So now we have to find the triplets I, j, k such that nums of I plus nums of j plus nums of k equals 0. So again you have to sort the array, and instead of 2 pointers, over here we will have 3 pointers. So we will have I over here, which is going to be fixed for one of the iteration. Then we will have j over here and we will have k over here. Now what you're going to do is you're going to apply the same 2-pointer theorem over this part of the array. Correct. So over here you will check for nums of I plus nums of j plus nums of k. So in case this value is actually greater than 0, since I is fixed, you can only move j and k, and since the array is sorted and since the value is greater than 0, you have to actually decrement k so that this value decreases. This entire value nums of I plus nums of j plus nums of k decreases. In case this entire value is less than 0, you have to increment j. And in case this is equal to 0, you have found one I, j, k, so you can simply put this into your resulting list and you can increment j and you can decrement k. Correct. So over here what we're going to do is, since I is fixed for the first iteration, so once this iteration is done, I will actually come from here to here, that is over here. We will simply, so j will be here and k will be again here, so we'll apply it over this part. So similarly we will move. So let me just show you the code for this thing. So if you see, we have a resulting list over here and we are simply sorting the array given to us. Now we are iterating over I equals 0 to I less than nums.length minus 2. I'll tell you why we are iterating over this length. Then we will have j as I plus 1 and k as nums.length minus 1. That is, they are the left and the right extremes of the rest of the array, correct? Then we will loop while j is less than k, and we will check. In case this is greater than 0, we will decrement k. In case this is less than 0, we will increment j. And in case it is equal to 0, we have I comma j comma k. We will add to the resulting list and we will simply increment j and decrement k, correct? So the question is why we are over here. So if you see this 5, this actually is also n minus 1 index. This is actually n minus 2 index, and this is actually n minus 3, correct? So if you see, I can only come till this point. Why? Because we have to find a triplet. So we need at least 2 values in this list, correct? That's why I can only reach over here. That's why we have I less than nums.length minus 2. So let me write the code for this thing and then things will be more clear. So first we will do the null check, that is in case nums equal null or nums.length equal 0, then you will simply return a new array list. After this, what we are going to do is we are going to simply sort the array given to us, and we will also maintain a list of integer that we have to return. This will be result new array list. Now let me iterate over the array. So we will have for int I equals 0, I less than nums.length minus 2, I plus plus. We'll maintain 2 variables over here, j which is equals to the left extreme, that is I plus 1, and k which will point to the right extreme, which is nums.length minus 1. Now you will have over here, while j is less than k, you will check in case nums of I plus nums of j plus nums of k. In case this is greater than 0, we will simply say k minus minus. Else if this value nums of I plus nums of j plus nums of k is less than 0, we will simply increment j. And else we have found one triplet, so we will say result dot add arrays dot as list, and we will provide over here nums of I comma nums of j comma nums of k, and we will simply increment j and decrement k. And after this loop is done, we will simply return the result. Now this won't give you a correct solution, and I'll tell you the reasons. Let me just run it once. So over here, if you see, this is our answer and this is the expected answer. So if you see in our answer, we have one more minus 1 comma 0 comma 1. So actually, if you see in the question, it is given to us that the solution must not contain duplicate triplets. So actually we are adding duplicate triplets. So how can we avoid this thing? So if you see, any triplet is actually can be identified only by the 2 numbers of the triplets. What I'm saying over here is, so if you see in this triplet, if I know 2 of its numbers, that is if I know minus 1 and 0, and the third number is x. Now the value of x needs to be 1. Why? Because this sum is 0. So what I can say is I can identify this entire triplet using any 2 of its numbers, correct? So what I can do is I can create actually a set of pair of integer, and I'll identify all these triplets using the 2 numbers, correct? So that we are not adding a duplicate triplet into the set, correct? So let me just make those changes. So first we will create a set of pair of integer comma integer. So we will have set of pair of integer comma integer. We will have set equals new hash set. Now before, so in case nums of I plus nums of j plus nums of k is equal to 0, we have to check whether this triplet is present in the set or not. So So in case this is not present in the set, that is, we will have over here new pair. We can identify the triplet using any two integers. So let them be nums of I, comma, nums of j. So only in that case we will add it to the resulting set, correct? So let me just actually, and after this thing is done, we will have to add this pair to the set. So we'll have new pair and we will provide nums of I, comma, nums of j. So what I'm doing over here is, since we require only unique triplets, I can identify any triplet using a pair of integer comma integer. So that's why we have a set of pair of integer comma integer. And when we are hitting nums of I plus nums of j plus nums of k equals 0, I'm checking whether this current triplet, which can be identified using this pair, is present in the set or not. In case it is not present, you know that this triplet is unique. You will add it to the result, and then you will simply add the pair to the set, correct? So let me run this code one more time. So it's giving the correct result. Let me submit the solution, and it got accepted. So I guess that's it from this video. In case you have learned anything from the video, you can hit that like button, and in order to support my work, you may consider subscribing to my channel. Thank you all.